In this video, I'm going to show you how to use the software development lifecycle in the development of a software. Now, the software development lifecycle is a process that has got stages that are taken when a person or a company is developing a software. It usually starts with a business case where a problem that the business is facing, and the business is now trying to come up with a software that can solve that problem. And the result of the software development lifecycle is a fully functional software that is deployed for use in the organization. Now, some of the benefits of a software development lifecycle include clarity of the problem that you're currently facing or the goal that you're trying to achieve. The SDLC also helps in managing the project of developing that software so that you don't leave anything unattended to. It also helps in making sure that the system, before it's actually being used in the company, it is well tested so that it doesn't have any bugs. And it also helps in making sure that even if any member of the team leaves the team during the development of the system, you can always take on a new member without any challenges, and the system will still be developed as initially intended. And finally, it also provides continuous feedback until the project has been delivered, and this helps in making sure that you don't waste money developing something that people do not want, and you make sure that by the time you finish developing, you have got the right product for the right problem. So the software development lifecycle is made up of four main stages. The first stage would be the planning stage. The second stage would be the analysis stage. The third stage is the design stage, and the fourth stage is the implementation stage. Now I'll go through all the stages one by one, and I'll start off with the planning stage. So the planning stage has got two main activities. There's project initiation, and then there's project management. Now, I'll start with project initiation. So under project initiation, you're looking at starting the project. So usually it starts with the identification of the problem. What is the problem that we're currently facing that we want to solve using a system of some sort? And then when the problem is identified, a business request is sent to the IT or team or to the developing team so that they can understand what is it that the business is facing as a challenge and how they think or they want it to be solved. Once the request has been received, a feasibility study is done. So the feasibility study basically checks to make sure that it is possible to actually develop this system that people want. So we want to make sure that we don't start developing a system that is impossible to actually develop. And then we also do a cost benefit analysis to see, to see if the development of the system is actually worth it compared to the cost of developing the system. So at times, some of the solutions may be good, but they are too expensive for the business for it to actually realize enough value to recoup all those costs that would have incurred. And then we move to project management. Now, under project management, since you have already done your feasibility study and your cost benefit analysis, and you have seen that the project is worth doing, you're now looking at organizing the actual project so that you can start developing the system. So the first thing you do is you choose your project management team, then you move to scheduling. So the project management team will handle things to do with schedules, to do with cost, to do with team building, to do with identifying the milestones and deliveries, and every other thing that project managers are supposed to be doing. So basically, project management is just coming up with the structure of the project, how it's going to be done, who's going to do what, and how can we actually determine whether we have achieved our goals or not. So at the end of this planning stage, after you've done your project initiation and your project management, the main deliverable or the main product of that stage is the project plan. So at this stage, you have a project plan that you're now going to use and take to the next step. And the next step is the activity, is the analysis stage. Now, don't forget to subscribe if you want more content like this. I'll be uploading weekly videos on many IT issues. Now, coming back to the software development lifecycle, we have got the analysis stage. Now, under the analysis stage, we'll start off with the development methodologies. So, in coming up with your system, you choose a certain way or method that you're going to use or follow as you develop your system. Now, the main methodologies I'm going to look at include the waterfall method. Basically, the waterfall method is a method where once you start something and you finish it, you cannot go back and correct it if you made mistakes. So once you do it, it's done. You cannot go back. And I'm not going to explain fully how it works, so you can look for other videos that can explain the waterfall model. But basically, once you start something and you finish it, if you finish a stage, you cannot go back and correct where you made a mistake. You have to continue. So that's the waterfall model. Then there's the agile method. Now, the agile methodologies basically the idea is you can go back and forth across all the various stages of developing your software, so that wherever you made a mistake, you have the opportunity to correct it. So some of them include RAD, which is Rapid Application Development, and JAD, which is Joint Application Development. Now, there are many varieties of agile software development methodologies, but basically the main core concept of them is you iterate through all the stages until you get your system right. Then there is a spiral model. Now, the spiral model is more like a combination of the waterfall and the agile, where where in one iteration you actually use more like the waterfall model, and then once you're done with that iteration, you can now start again. You can evaluate what you've done and start the process again. Once you're done again, you evaluate, and in so doing, you create what is called the spiral model. Again, you can look around and find more information on the spiral model. So once you're done with deciding your development methodology, you now move to gathering the requirements. So what are the requirements of the system? Now, in the gathering the requirements, some of the methods you use include interviews. So you interview people who are facing the problem. What is it that they are facing? What's the challenge? What they expect? Or you can also use questionnaires so that the people can fill in and you get more information. Or you can use focus groups where you can discuss with people with the challenges that you're facing and how they can be solved. You can also do observations where you observe the people working in their environment, and then you try to note the challenges that they are facing as they are working. Or you can also do document analysis where you actually get documents that are being used in the environment where the challenge is, and then you understand, probably it could be system documentation or it could be process flow documentation, and then from that analysis you can see where the gaps or the bottlenecks are. So from the requirements gathering stage, we move to the requirements analysis stage. Under the requirements analysis stage, you're now looking at, you have found your requirements, you have been given the requirements. Now you need to analyze them to see which requirements work, which requirements don't work, which requirements cannot work together so that you can trade off, and which requirements bring out the best that the people want. So as part of requirements analysis, you will use a number of diagrams. And some of these diagrams include the data flow diagram. So with the data flow diagram, what you're doing is you're looking at how does data flow within the system. How does data flow from or move from the users to the various modules in the system, maybe to be stored in the database, how it's retrieved, how it's used in the various modules, and how it's sent back to the user. Then you also have the state diagrams, which shows you the various states that the system goes into as you take certain actions. Then you also have the activity diagram, which shows you the actions that can be taken when you are in a certain state. So the state diagram, the activity diagram are basically more or less like opposites of each other, but they complement each other in that one shows more of the um, actions that can be taken in a state, and the other one shows you the states that that you result in after taking a certain action. Then you can also use decision trees and decision tables so that you can map out how taking a certain action can lead you into a certain state. So, for example, you can have a table that says, if you take this action, then this is the result that you're going to have. If you take this action, then this result will lead to this kind of action or this kind of response from the system. Then you also have use case scenarios where you can actually model how a certain user is going to use the system. So with use case scenarios, it's like you're having a walkthrough of if the various users of the system are going to experience the various things that they're going to do within that system. Lastly, you have got class diagrams and sequence diagrams, which basically go deep down into the code and show how the various modules or methods or functions or objects are called and used within the code base of your system. So once you've analyzed your requirements, now you need to look at how you're going to actually develop the system. So when you're looking at how you're going to develop the system, you have to consider whether you're going to do a horizontal or a vertical application. So a horizontal application is one which is basically takes care of, which is generic in essence, whereas a vertical application is one that is more specific and more custom made for your problem. Then you also decide whether you're going to do insourcing or outsourcing. Insourcing, whether you're going to develop it in-house or you're going to actually hire some other people to come and develop your system. And you also need to consider whether it's going to be a custom made system, which is made from scratch for your specific organization, or it's going to be a system that you buy off the shelf, which is the commercial off the shelf system, something that has already been made by someone, and you're going to buy it and probably customize it to suit your needs. You also need to consider your your deployment environment. Is it going to be a private or a public cloud? And you also need to consider whether you're going to do it on physical hardware, it's going to be a virtual machine, or you're going to containerize your solution. You also need to consider things that include the tiers of the architecture. Is it a client server architecture? Is it a 3-tier architecture? And how are the various modules or components of your software split among these various architectures? So these are some of the things that you need to consider, but you can also consider many more things considering your operating environment, your development environment, and how you want to eventually use the system. So once you've finished the analysis stage, the main deliverable or the main product of this stage will be the system proposal, which will now show that given this problem and these requirements that we've gathered, after analyzing them, we have realized that this is probably the system that we can develop. This is the possible solution that we can use. And once you have that system proposal, then you move to the design stage. So at the design stage, you're now going to choose the right technologies to be able to develop or implement your system. These technologies include looking at the programming language and the platform that you're going to be using. You also need to look at the database platform. Are you going to use a relational database, a graph database? Are you going to use SQL Server? Are you going to use Oracle or DB2? You also need to look at the hardware specifications. How much RAM do you need on your system? How much disk space? How much processor speed do you require for you to be able to run your application fully? Then you also need to consider whether you're going to virtualize your system. And if you're going to virtualize it, which platform are you going to use? Is it VMware? Is it Zen? Um, and the like. And you also need to consider whether it's going to be the public cloud or a private cloud. Then you also need to look at the quality attributes of the system. How fast do you want the system to be? That's your performance, your security. How secure should your application be? You also need to consider and design issues to do with how many transactions it can handle at a certain time. How many processes can it run at once? So those are some of the issues now that you're now considering. And based on those issues, you choose the actual technologies that you're going to use in developing the system. At this stage, when you're done with the design stage, you then come up with the system design solution. Now, once you have your system design solution, you get to the implementation stage. At the implementation stage, the first thing that you're going to have is you're going to do is the testing of the system. So as you test the system, you're going to follow you're going to do unit testing first, where you're going to test each unit of your system. Then you do module testing. You've got various modules, and some of these modules are made up of some number of units. So you test that integration as well. Then you get to the integration testing, where you're now testing the various modules integrated as subsystems and seeing if they can work together. And you then test the whole system as a whole under system testing. And whilst you're doing all these tests, you also need to look at quality attribute testing, where you're testing things to do with performance, security, load, stress tests, and all those kind of tests to make sure that your system is ready for deployment. Once you're happy with that and you think your system is ready for deployment, you move on to the changeover strategies. And at the changeover strategies, you then use one of the strategies you can use is the pilot strategy, where you can actually test your system with a subset of all the employees or branches or environments in which it will be operating. So you just take a subset, and those people will test the system. If you're happy with it, then you can roll it out to everybody else. Or you can do a direct changeover, where you actually just remove the old system and you implement the new system for everyone, and it happens immediately. You don't have to do some slow rollover, but you just do a direct cutoff and you remove the old system and introduce the new system. Or you can also do a parallel run, where you have the new system and the old system running together at the same time, and you observe how they work together. Or you can do a phased approach, where you can implement the new system or the new changes slowly in the organization. For example, by department from department, where you introduce in the sales department first, then you roll it into the marketing, then into IT, until everybody finally uses that system. Once you're done with implementing and deploying the the system now needs to be maintained. And part of maintaining the system includes handing over the system to the support team so that they know what to do and how to keep the system running at all times. There's also need to actually safeguard the documentation of the system and to make sure that it's there so that everybody knows at any stage what the system is made of, what changes have been made over time, and how it's actually working at the moment. Then, when it comes to making some changes to the system, you use your usual operations processes within the organization, and that will include for change requests, for incident and problem management, and the like. And this will be dependent on how your organization approaches the maintenance of that system. Once you're done with that, then you're done with your software development lifecycle. So I hope you subscribe to the channel so that you can get more videos like this.